Here's another one. This is fun. This is in 9, kind of. This is, so, here's a function. And it looks a lot like the sum of a geometric series to me, thinking about this formula. Of course, actually, this formula has the one, let's see, I need to have a minus sign, so just a little manipulation here. I'm going to have to write it like this, and therefore my a is a 1, my r. So this function becomes this series, negative x to the n. My r is a negative x to the n. And, you could, if r is negative, you're going to be multiplying by a negative. It's going to turn in, the next term will be negative, the next term will be positive, the next term will be negative. The train's coming. So then we get a negative 1 to the n times x to the n. I mean, that's just another way to write that. So this series is this function. Remember this function, 1 over 1 plus x. All right. All right. That was easy. I hope you talking fast, but anyway, and then it converges on, this is the interval of convergence, when x is between negative 1 and 1. All right, so this series for those x's converges to this function. Now, I don't know, you might not have known you can do this, but what if I wanted a series for 1 plus x squared? Well, I can replace all these x's with an x squared, and so I get this series. X squared to the n. Replace x with x squared and you get this series. So now you just built a series for 1 over 1 plus x squared from using this known series. This series is known to be this function. Using that, I've got this, which is, you could simplify that and call it, let's see, when you multiply powers, that's x to the 2n. All right. That train gets loud. I'm going to talk loud. So, I was going somewhere else. What if I wanted a series for the arctangent of x? That seems like that's out of the blue. But guess what? The integral of this is arctangent. So if I just integrate this, I'll have a new series for arctangent. So all I got to do is integrate this. This is a whole bunch of terms. And when you integrate each of these x's, how do you integrate an x to a power? You do the power rule. You add 1 to it. You're going to get this series. This negative 1 to the n is just a constant. You're going to get x to the 2n plus 1 over 2n plus 1. Remember how to integrate? Power rule. Add 1, divide by that power. So we just created a series for arctangent of x using this idea. I thought that was pretty cool. That's what we do up in 9-10. In 9-10, there's a lot of famous series. We take them, we manipulate famous series to create other series. So we're headed there. Next. I thought you would like that problem. Same interval of convergence, by the way. Negative 1 to 1.